morning and welcome back to the old steam-powered machine shop. It's really good to be back in the steam-powered shop again. Took a while, but we got everything back together. We got the boiler back together and the piping back together. Made a few modifications, I'll show you, to the steam lines, and did a few things to the boiler over there to kind of make life easier for the firemen. Got a few projects going in the shop. I wanted to tell you, I'm sort of changing gears here. I've been involved in the engine, the big engine automotive truck, tractor, marine business for quite a few years, and it's been a good business, and I'm retiring out of that, and I want to do this full-time as a semi-retired person, and hit and miss engine rebuilds, steam, and I want to try to overhaul and repair as many different types of steam engines as possible, so I can kind of see what the good points and the bad points were of each one, and try to kind of read the story of the way they were designed. A lot of the designs were, you know, you wonder why they did it this way. It doesn't seem like it makes a lot of sense, but a lot of times they were trying to get around patents that other companies had, so they didn't have to pay the royalty on the patents. And anyway, I want to try to come up with a very simple design, about a 5x5 engine that I can actually build here in the shop. And of course, the big news for me is I found a couple of engines and was able to buy them this winter. One is it's a 8x10 engine. It's kind of big, and it was built by the Richards Iron Works company in Manitowoc, I think it's Wisconsin. And it's out in Wisconsin. I got to go pick it up, and it's a really cool engine. It's pre-1900. I can find nothing about engines, steam engines like that company built. They were mostly involved in building lake freighters, tugboats, marine engines, and later you'll find Richards Iron Works in I'll say the early 20s in Popular Mechanics magazine, advertising small gas-powered marine engines, 1, 2, and 4 cylinder, but nothing on steam engines. So I don't know if it was a one-off thing that they built for their own factory or what, but anyway, it survived, and it appears to be in running shape, governor and everything. And also another little engine, it's out at Jonas Stutzman's shop. It's a Lilly engine, and if you research that, you'll see they were built in Jamestown, New York. This is a small engine. I believe it's a 5x5. It's about the same size and configuration as my shop engine here, and that's complete. It's been laying outside for years. It'll have to have a complete overhaul on it, I'm sure, but I thought it was a fairly rare and unusual engine. We got some things going in the shop. One thing is the Florida Flywheelers had a 7 horsepower economy hit and miss engine that they were going to set up on their line shaft. If you go back a couple videos, you'll see when they were building the pulleys for it and everything. Well, they got it all set up to go, and the engine wouldn't run, and the magneto had some problems, and they got that fixed, and then it had no compression, and pulled the piston out of it, and the cylinder is all gouged up where the wrist pin sometime in its life has got loose. So we're sleeving it. It's a 5 3/4 bore, and the sleeve will be 17.5 inches long. So that's really a job for the horizontal boring mill. And the Morris engine, Tom was gonna build a wrist pin for it, but the stock I got wasn't the right size, so I had to reorder that, and that should be in this week, and that'll be in the next episode. So I grabbed a pulley out of my stash that looked like it'd be about right for the Morris engine, and remachined that all over, and bored the hub out to the right size for the crankshaft, and broached the keyway in it, and some other things along the way. Anyway, I don't want to yak too much here. We're going to get right to the machine shop work. I want to thank you all for all the comments and the subscriptions, and I got to tell you, the comments are what keep me going on this thing. I mean, this is sort of like your guys' channel. All I'm trying to do here is just pass on some things that I learned along the way from some old timers and what I've read about, and you may see a lot of these operations in old shop manuals, and this is a chance to see them actually done with actual stuff. So that's what the channel is all about, and thank you very much for your support. So we'll get to it. This is one of the last things that has to be done to the crankshaft. If you've been following along on some of the previous videos, these counterweights here were remachined to fit on, and they're bolted on. We originally thought that one of them got loose and that's what caused the damage to the engine that took it out of service, but I've since decided that that's not the case. I think something fell into the engine and broke one, and a mechanic ordered up a new one, and it never got put back together again, and the engine never got put back in service because the crank was bent. So these counterweights are remachined to fit on here nice, and grade 10 bolts pulled down really tight and welded. And now I have to pour the babbitt back in like it was around the bolt to add weight to the counterweight, and also to lock the bolt in place. So I've just got some plywood pieces dammed up here on the side, and I got some babbitt going here. It was labeled unknown babbitt, but it looks like pretty good stuff just from what you can tell by looking at it. And get the dross out of it. I didn't preheat the crank because my setup with the plywood there was not too conducive to heat. But I'm going to try it. It doesn't really have to do anything but lock in. The notches in the crank are dovetailed, so it can't go anywhere. It's basically just a finishing step. Okay, I'm going to move the camera over here closer. That side. Do one side at a time because it's kind of clunky with the dam up and the clamps. Well, we'll let that cool down and pull the dam off and switch it over to the other side. Well, that side turned out pretty well. You might get lucky twice. Okay, we got the boiler filled up. This is the first fire of the year. Crankshaft mics out at 1" 9/34. Quite a ways to go yet. Long pattern so it doesn't shatter. We got to take on a little water, and I'll show you some things that I did this spring. I replaced these two check valves here because they were giving me fits last year. And these are Chinese stainless steel, the best I could find for the money, and they appear to be working okay. I also built an overflow catch pipe here. It's just a big pipe that's piped down into the drain. Just keep the steam from blowing all over everything when you start the injector. Okay, so This is the Metropolitan Injector, number 9N. Working good. I'll show you this one here. This is the Hancock Inspirator. It's, like I said before on some earlier videos, it's actually a double injector. It's one injector that pulls the water up to the injector, and another injector that injects it into the boiler. So we turn on the water, open the overflows, turn on the steam. It's a little more complicated to operate. Tom doesn't like it. That gets the injector started. You close the top overflow, close the bottom overflow. And there it goes. And this injector will work down to a very low steam pressure. We got about 60 now, so that's probably what we run at. It works good at that pressure. Last pass. You had a bit of a dilemma here the other day. The main drive belt from the engine to the line shaft finally gave up. This belt is over 100 years old, I'm sure. And I've been using it ever since I set the line shaft up, and I've been kind of being careful with it and kept the oil on it and everything, but it was kind of an unusual failure. It never broke, and it never pulled a lace out, and it really wasn't too tight, but it got good traction, but it just got so it wouldn't stay on the pulley. Tom and I tightened it up, the other day, and it ran fine. The next time I went to start the engine up, it slid off and got into the flywheel, chewed it up, and you can see I can tear it with my hand. It held on as long as it could. I hate to give it up, but the cow would have been quite pleased to know that its hide lasted this long and was this useful. Leather belts this size are hard to come by, and the new ones are really expensive, and it's not as good a leather. So I looked through my stash and I found this old thing, and I don't know if it'll run or not. It's really been through the mill. It's got a repair splice here and a couple other places. It's just a little bit wider, and it's 2-ply. It's double thickness, but it's quite flexible. So I'm going to cut it and splice it and put it on, run it and see how it goes. New belt on here. I coated it with each foot oil, rubbed it down, scraped the inside surface, made sure I had it on the right way around so the splice is in shape, and lined up the engine a little bit, and looks good. Here's something I wanted to show you. Most people alive today working in the machine industry don't know, or the old timers have forgot how bad this material was. This is a piece of line shaft that I saved just to make, I'm trying to make an arbor here to put the pulley on. It doesn't have to be anything tremendous, but I don't know if you can see these lines in here. This is wrought iron, and what they did was they partly purified it in a crucible by blowing air through it, and then they poured it out. It was like a big wad of spaghetti out of the pot, and they hammered it together and formed a rod, and then when it solidified and cooled, they turned it on a lathe. So it's not homogeneous. It's got layers of slag. You can see the layers go this way, and so when you try to make something out of it, you run into this. It's like machining a piece of roast beef. When steel came along, it was quite a thing.
Okay, I hope you can see this. The taper attachment is set up for a little over a 1/4 inch per foot. So now I got to go the other way with it to do the other side. So that's the same on the other side of 0. Okay, this is good because we got both angles to meet in the middle. It's pretty close. Two and a half. There you can see what I was trying to do with the taper attachment. That crown needs to be in the middle of the face of the pulley in order to make the belt run right in the middle of the